Welcome to another episode of Wes Explains Best. Today we're going to the mailbag. I received an email from a student asking how to do this geometry problem, so I'm going to show how to explain it. And if you ever have a problem yourself and you need some help answering it, send me an email with the image and I will do my best to answer it in a video for you. So this problem is talking about regular polygons and asks us to find the area of the shaded region. So anytime you have a shaded region problem, you generally are going to use this following system. You're going to take, let me use my highlighter, you're going to take the entire area of everything. Okay, so this is we'll call it the area large. So that's the biggest area that we can have. And what you're going to do is you're going to subtract everything that you don't want. So the non-shaded region is this red area. So you're going to subtract the area of the non-shaded. And that will tell you the area of the shaded. So this is a kind of like a surefire system for you to be able to find the area of anything. The whole premise is you take the big area, subtract what you don't want to include in your area, and it makes it a lot easier most of the time to do that versus something else, okay? So let's go ahead and start applying that. So we need to start with finding the area of the large polygon. Now this polygon is a hexagon, and because it's regular, we're going to use this formula, which is area equals 1/2 times the perimeter times the apothem. Now the apothem is a distance that looks like this. I'm going to draw it on the small one first. Okay, so that is the apothem. It's perpendicular to the midpoint of a side, and it goes to the center. Now, what do you call this distance here that goes from the vertex to the center? This is called the radius. Okay, so it gives us the radius of both the small, but look at the big. It doesn't look like it gives us the radius of the big, but it really does, because we could swing this. Let me grab it real quick. We could swing this little guy over to the right. See how we could swing this radius over to the right? And it's still 7, and now it connects with the other radius. So if we connect the two radii, if this is 7 feet, then we know that the radius of the big hexagon is going to be 14. And that's a very key piece of information. All right. Now, when we're talking about hexagons, that's actually one of the easier regular shapes to handle when it comes to solving regular polygons. And the reason is, if you divide a regular hexagon into triangles, it has a special property. Now, we could find the central angle for one of these triangles by taking 360 degrees, okay, them out in a full circle, and divide it by the number of sides, the number of triangles that we have, and you'll see that we get 60. Once we get 60 here, we know this is an isosceles triangle. So what happens is these two angles need to be the same. And so we need to say 60 plus 2x equals 180. You solve for x, you end up getting 60 and 60. So these always form 90-degree, equilateral triangles. So if that's equilateral, then we know that one of the pieces of information that we need, which is a side length, we can find that pretty easy because it's part of the side of a triangle. So this is going to be 14 feet. So now we can find the perimeter pretty easily for our first guy, which is the big triangle. We're going to solve again for big hexagon. We're solving for the big hexagon first. Okay. We already know that the perimeter is 14 times the number of sides, 6. Okay, so we can do that. 14 times 6 gives me 84. So you already know that this is 84 for the perimeter. We're off to a good start. But now we need to find the apothem, which is a little bit more difficult, but it's not too bad. Okay, going back to our little sample drawing here, we're looking for the apothem, and the apothem is this line here that is from the midpoint of a side and it's 90 degrees, the apothem. Now we already know that this distance here is our radius, and this is 14. And since it's the midpoint of a side, we know that this distance right here is 7. What else do we know? Well, we know that this angle is 60, but now we cut it in half because of the apothem, so this is now 30 degrees. I hope you guys recognize what 30 degrees means for this particular triangle. It means we have a 30, 60, 90. So what we're going to do is we're going to finish drawing it enlarged, and we're going to use this to help us out. So the principles of a 30, 60, 90, let me copy and paste this. Copy, paste. Principles of a 30, 60, 90. If this side is opposite 30 degrees, we usually call that's kind of like our go-to side. So the hypotenuse is twice as big, and the side opposite 60 degrees, the medium side, is x, whatever that side length is, times radical 3. So we do already know that the small side, the blue side, is 7, the opposite 30 degrees. We already know that this is 14 because of it's 30, 60, 90, and because it's equilateral triangle, we solved that first. So therefore, we just need to multiply 7 times radical 3 to find our medium side. So that is our apothem. So we're going to go back over here, and we're going to plug it into our area of our large hexagon times the apothem. Now we know what it is. It is 7 times a radical 3. 7 times radical 3. And now we're going to simplify this. So we're just going to go to our calculator here. It's asking for the nearest nearest tenth, so we know we're not going to leave it in radical form. So we're going to do 84 times 1/2 times 7 times radical 3. And I get 509.2229374. Now I'm going to leave that stored because it says do not round until the final answer. And that's generally the appropriate thing to do. You want to keep everything exact and stored on your calculator as possible. And then once you get to the end, then you're going to round it. Okay. So now we're done with the large. Now we need to go to the small guy. So we already had some information about the small hexagon. One of the things we knew is that the radius was 7. We already know, since it's a regular hexagon, 7, 7, and this must be 7. Okay, so let's go over here, and let's call him, we should be using red, the area of the small. Let's call this big L for large, L. Call him small, equals 1/2 the perimeter. So we already know one of the sides is 7, so the perimeter is going to be equal to 7 times 6. And now we just need to find the apothem. Okay, let me go ahead and do that. Area equals 1/2 times 42. I'll leave that in parentheses. Times. And now we need to find the apothem. Okay, so very similar case. I'm just going to copy and paste this guy. It's going to be another 30, 60, 90. Because it's still a regular hexagon. This time, though, the purple side is 7. Because we're dealing with a smaller hexagon, half the size. So therefore, half that side length is going to be 3.5. So then we can do 3.5 times radical 3 for the apothem. 3.5 times radical 3. And I'm just going to show you what that is in decimal form real quick. That is about 6.06. Okay, and I'm not going to round it. I'm going to put that whole thing in there soon. That's our apothem, A, times 6.062177826. Okay, I'm just going to round it right here just so I don't have to write that all over again. So I'm just going to take that times 42 right away, times 1/2, and I get 127.3057344. Sounds like a phone number, doesn't it? Okay, so now I have my orange, I have my red. So what I'm going to do is, because I already stored the values, I'm just going to take the orange, 509, minus the red, which is 127. I hit enter, and what I get for my, let me go ahead and write that out. So I took 509 minus 127, and that equals 381, sorry, that's a 3, 381.917.203. So if I'm rounding to the nearest tenth, that is going to be 381.9, and it is feet squared. Final answer. So I hope you found this video helpful. Just keep in mind that anytime we're looking for the shaded region, we take the whole region first, minus the area that we don't want, and that will tell us the area of the shaded region, okay, which is the area that we do want. So the main process of finding the area of a regular hexagon is taking the radius, understanding it's an equilateral triangle, dividing it up into a smaller triangle, realizing you have a 30, 60, 90, using the properties of 30, 60, 90 to find the apothem, multiplying that by the perimeter, multiplying by 1/2, and then inputting it into your general equation. Hope you found this helpful. Send me some emails if you have any questions, and be good, be kind, be true, be nice, and be honest. Have a great day.